Good morning, good afternoon, everybody. This is Howard Lowe from DataON. Very happy to have our guest partner here today, Vaibhav from Intel, with me for our Ask the Expert series, where we're just having casual chats about technologies and the solution that we deliver to our end user. So, Vaibhav, can you do a quick introduction to our audience?
Hey, thanks, Howard. Thanks for having me. I am a business development manager or focused on scaling Optane solutions in the channel, but I belong to the NSG business unit at Intel. And it's usually an O plus Q story. It's always Optane and QLC. So I focus on all SSDs. Not too long ago, I think in the recent past, I was a strategic planner in the same division, planning our 144 layer TLC and QLC SSDs. So I'm here. I'm glad to talk.
You have a broad portfolio, Vaibhav. Seems like you know everything, so you're the right person to talk to. Yeah, I'm very happy to have you here.
I'd say I kind of dabbled a little bit in everything. I think I even did embedded SSDs at Intel. So hopefully I can cover the whole spectrum.
Yeah, just to set it up, DataON as a hypercloud computing vendor continue to work with our partners, strategic partner, on building the right solution for our customer based on Microsoft Azure Stack HCI. And clearly, Intel is one of our partners that we always tell our customer, not only on the server side of it, with all our server and chassis, our motherboards are all from Intel, made by Intel, but all the other building blocks, people think about Intel as mostly processor company, but clearly, in addition to processor, DataON leverages and build the Intel storage technology into our solution. And today, I really, that's the discussion we're going to have is really in the Azure Stack HCI space where we deliver a complete turnkey solution to our customer to run their mission critical production workload or converged storage workload. How do we make sure we get there, and how does Intel help us get there? So Viva, maybe as a setup, one of the key solution that we design for our customer in the all-flash world could be in the extreme on the right side, which is the Lamborghini of the world, which is all flat, Intel NVMe, the TLC version of the P4510. But recently, we've been doing a lot of tests, and we actually have a couple customers also starting to adopt the Optane plus QLC design, which give you the performance you need plus the capacity they want to run their workload. Can you describe about kind of what those configurations look like, why Intel is really committed to this market?
No, I think that's the age-old trade-off that we've been dealing with is performance versus cost. If you put too much performance, you got to pay for it. And really, the story comes together when you put Optane and QLC, and we kind of start to talk about, can we get an and instead of an or, right? We're living in the world of ands anyway. So let's begin with the crux. Like most people will argue, 4 bits per cell is 4 bits per cell. You'll get some cost savings. But Intel's choice of floating gate and then using the CMOS under the array, we started to differentiate our QLC on reliability, aerial density, and endurance as compared to what other QLCs are out in the market. We've already demonstrated enterprise-grade QLC SSDs they're in production and being deployed. And we're already pushing to double the PE cycles and get you more endurance from QLC, which is a good stepping stone for the solutions that you referred to, Howard. Intel's choice to bring QLC to market first on NVMe instead of trying to bring it on SATA or some of the slower interfaces, first with PCIe 3.0 and upcoming with PCIe 4.0, means you're able to deliver pretty impressive read bandwidth, right, from a very affordable media. But it's not just the media level optimizations. At the SSD level, we've done choices where we moved to a higher indirection unit, made some BOM level tweaks. We're trying to make it as cost optimized as we can, so that if you're capable of shaping your write, you can really deliver or get yourself an extremely cost optimized capacity tier. And that's where Optane steps in and says, you know what? Here's why this is a marriage made in heaven, if you may. Because Optane can get you amazingly great performance, extremely low latencies, and you couple that with a dense and extremely affordable QLC media at the capacity tier, and you have yourself a solution that can compete with the all-flash, can actually deliver better performance without going overboard on cost. Hence, we don't have to think about the age-old cost versus performance trade-off.
It's actually very realistic what you're saying, because in the real world, today, we sell a lot of flat NVMe design, but more and more people really want that capacity. And the fact that a QLC could deliver right now, I think that the design we have in one of the customer deployment is 16 terabyte QLC media, which is incredible in terms of capacity. For them to really put their workload in a flash tier, but by having the Optane in the front, it really. Recently, we did we worked on a benchmark test with storage review, and hopefully they'll come out, and they came out with a report that really put it Optane plus QLC in a 2-node configuration, running some SQL workload. Even in that environment, the performance was incredible, and that's something that we're really surprised about.
Yeah, no, I think I believe that 100%. The Optane's value, and you talk about SQL, Microsoft SQL has this tempdb that gets used. Tempdb is what? It's an overflow for when the DRAM fills up so that you can have some of the table writes happen there. And we've seen even in simpler deployments that using tempdb on an Optane as a cache can improve your overall performance. You can actually start looking at DRAM footprints going down if you really tweak your system. But just by caching your tempdb, you can see massive improvements with Optane. And the Optane improvements don't come necessarily just by throwing it in there. The media itself is capable of doing so much more than what NAND could do. Right? It's fundamentally different. It's not like DRAM when it comes to scaling. You can go up. We've already demonstrated stacking capabilities with the media, so you can grow capacity. So your caching tier now doesn't have to be limited to small capacities. You can grow that. And when you look at speeds and feeds, it starts to compete more with DRAM. So it's truly fundamentally different, which can revolutionize how you build solutions, how you looked at solutions in the past, and how you should be designing solutions of the future.
And incredible, it's a good fit. In the Microsoft Azure Stack world, they leverage the cache tier as kind of the tier for rewrite cache. And before you go into the second tier, and having Optane SSD in the front of the caching makes that entire process so much more efficient across the board. So, seems like more and more our customers asking for this design, and more we're designing this to help the customer achieve both performance, but still reaching the capacity they need. Here's workload they have in their environment.
Yeah, and maybe I should also add, like when a caching workload gets discussed, when we've talked about Optanes in terms of low latency, consistent latency, extremely amazing read performance under write pressure. All of these are performance metrics, and they're extremely important for the cache solution that you build. But the endurance aspect of Optane, we're talking about 60 drive writes per day. Medium endurance, NAND SSDs, 3 drive writes per day. You put that against an Optane, which is 20x more. A caching solution is meant to be written, overwritten, almost abused to protect your capacity tier, because you want that data to be safe. Nothing like an Optane to front end all your writes, absorb the whole write pressure, and then you can ease your data into the QLCs or low cost media to protect it from longevity, right? You get more out of your drives now by putting an Optane as a cache. So yeah.
Clearly, a lot of our customers are really sold on this design, and more of our customers are adapting to it for their workflow. So what's in the future, Vaibhav? What's in the future for Intel in terms of continuing to innovate in terms of technology building block to help company like us, DataON, who's building this Azure Stack HCI solution, hybrid cloud, to ensure our customers have the best of the world?
So it probably goes back to Intel didn't spend all this time trying to bring a fundamentally new technology just to have a point solution, right? We're super excited, beginning with Optane first, and I'll touch on QLC as well. We're super excited with what the first generation of Optane did, but you would be pleasantly surprised and even amazed what the second generation does. It's already based on a media that has shown stacking capabilities, 2-deck, right, as opposed to the single deck in the first generation, which means we can now go from capacities ranging from 400 gig all the way up to 3.2 terabyte in the next generation. This is a PCIe 4.0 Optane SSD, so you can marry it with the high performance or the bandwidth of the next generation PCIe interface. But we've also seen customers get benefit on their existing PCIe 3.0 SSDs. I can talk more about this, but I guess the low latencies at lower queue depths and everything that we talk about Optane, you have to actually try it, and I can't share more on this call, but you'll be surprised, amazed, and as excited as we are when you get your hands on one of these SSDs. But that's not it. I think you've touched on an element of the cost trade-off. The current generation drives the P4326 with 15.36 terabyte. When we go to the next generation, we're looking to go from a 15.36 to a 30.72 terabyte. Now you think about pairing a 3.2 terabyte Optane in the front with a 30.72 terabyte QLC in the back, and your trade-offs are pretty much wiped off. You get all the capacity you need in a much denser form factor. We're talking about rulers and U.2s and so on and so forth. The space savings at the rack level because of what we did from the QLC cell and the Optane media in the front.
That is great. We can't wait until continue with the innovation that Intel's bringing to the table, and DataON and Intel has been partnered for 30 years, for a long time, and we continue to look to you guys to continue to innovate in terms of computing the building blocks we use for our solution for our customer. I can't wait to have the next conversation when those products are in play, where we're designing and giving to the customer and show our customer the exact data they get to really optimize for their workload. I really appreciate your time today, Vaibhav, and I appreciate sharing this knowledge with our customer, and looking forward to talking to you again.
Thank you, Howard, and thank you for being an amazing partner for Intel and playing along with our solutions.
Thank you, and have a great weekend.